Welcome to today's Explainer. Look, if you're a developer out there leveraging AI to write your code, you are absolutely going to want to pay close attention to this one. Today, we're unpacking a massive, really massive, upgrade to your coding workflow. We're diving deep into the official framework from the Claude code team at Anthropic to figure out how to transition from being just a manual prompter into a true agentic orchestrator. Let's get right into it.
So let me ask you, are you still manually prompting your AI for every single tiny little change? Look, it can be incredibly frustrating, right? You start to feel like a micromanager for your AI, constantly holding its hand, constantly hitting enter just to get it to fix a simple typo. Well, it is time to transition to Agentic Loops. We're going to break down exactly how to build agents that repeat cycles of work entirely on their own until a specific goal is met.
Here's the roadmap for today. First, we'll talk about how to stop being the bottleneck. Then we'll cover the for loop types. Third, maintaining high code quality. Fourth, managing your token usage. And finally, how to get started.
All right, let's kick things off with Section 1. Stop being the bottleneck.
You know, to really unlock the power of modern coding agents, you kind of have to change your mindset. You have to transition from being a pair programmer to acting more like a manager of systems. But what does that actually mean in practice? Well, according to the Claude code team, an agentic loop is defined really simply. It's just agents repeating cycles of work until a stop condition is met. That's literally it. It's all about designing the right triggers and stops so that the cycle spins entirely on its own, rather than needing you to babysit it and press enter every 5 seconds.
Moving right along to Section 2, the 4 agentic loop types.
We're going to explore how to hand off control of your process one strategic step at a time. This framework brilliantly illustrates the evolution of AI autonomy, removing from turn-based, stepping up to goal-based, then time-based, and finally, reaching the holy grail, proactive loops. Let's break down how you actually level up through each of these stages.
Okay, step 1 is the baseline. This is the turn-based loop. It's triggered by your prompt, and it's stopped when Claude judges that it's completed the task. Or, if it decides it needs more context. For example, say you ask Claude to create a like button. It reads your code, makes an edit, runs the tests, and then hands back what it thinks works. But here's the catch. You are still the bottleneck here. You're the one manually checking the work. To escape this trap, you need to start encoding your manual checks into a SKILL.md file. Doing this gives Claude the tools to see and measure the results itself, which totally cuts down on that endless back and forth.
Now notice the heavy contrast here as we level up to goal-based loops. With the manual setup we just talked about, you are the stop condition. But with a goal-based loop, you use the /goal command. By defining really explicit success criteria, something like pass these 5 tests or clear this specific score threshold, Claude doesn't have to guess what good enough actually means. An evaluator model will check that condition, and if it fails, it just sends the agent right back to work. It iterates on its own until the goal is truly met, or until it hits a turn cap that you've set up. You've just successfully handed off the stop condition. How cool is that?
Next up, we level up again to the time-based loop. Here, you are actually handing off the trigger. Because, let's be real, some work is just recurring. Things like summarizing Slack messages every morning, or checking a pull request to see if it failed continuous integration. For these kinds of tasks, you use the loop command to run the task on your local machine at a set interval. Or you can use the schedule command to run a routine in the cloud. It triggers automatically, does the work, and only stops when you cancel it or the task fully completes.
And finally, we reach the boss level, proactive loops. There is absolutely no human involved in real time here. Triggered by events and stopped by goals, this is where you start combining features like auto mode and dynamic workflows. Just imagine a system where a routine checks for new bug reports, uses dynamic workflows to orchestrate sub-agents that triage the issue, fix the code, and even review the fix, all without stopping once to ask you for permission. It's incredibly powerful for recurring streams of well-defined work like dependency upgrades or issue triage.
So this is where it all comes together. Depending on your loop, just look at exactly what piece of the puzzle you're handing off to the AI. In a turn-based loop, you hand off the check using skills. In goal-based, you hand off the stop condition using the /goal command. For time-based, you're handing off the trigger using /loop. And in proactive loops, you hand off the prompt entirely using workflows. It's honestly a perfect logic map for knowing exactly which command to reach for based on how well defined your task actually is.
All right, Section 3, maintaining high code quality.
Now look, I know it's thrilling to think about autonomous agents writing code for you while you sleep, but let's ground that excitement in some practical reality for a second.
If the system around your agent is messy, the output is going to be messy too. The Anthropic team suggests a few golden rules here. First, keep your code base clean because Claude literally mimics the conventions it sees. Second, use that SKILL.md file so Claude can self-verify its outputs end-to-end. Third, make sure your docs are easily accessible. And fourth, this is a really clever trick, use a second agent for code reviews by using the code review command. An independent reviewer has fresh context and isn't blinded by whatever flawed reasoning the main agent might have used.
Section 4. Managing your token usage.
This is a critical concern, especially for senior developers. If you have agents iterating continuously, you can burn through tokens incredibly fast. So how do we actually manage these costs? Well, first, match the model to the task. Please don't use a massive reasoning model just to fix a typo. Second, define incredibly clear stop criteria, so Claude doesn't just over-iterate forever. Third, pilot your dynamic workflows on a small slice of work first because these things can spawn hundreds of subagents if you're uncareful. Fourth, use standard deterministic scripts for things like filling forms. Running a basic Python script is way cheaper than having an AI reason through the steps every single time. And finally, always keep an eye on things using the /usage and /workflows commands.
And that brings us to Section 5, Getting Started with Loops.
We've covered a whole lot of theory today, but if you want to implement this framework right now, the Anthropic team offers this advice. Don't try to build a massive proactive loop on day one. Seriously, don't do it. Instead, pick just one task where you are the bottleneck. Just one. Ask yourself, can I write a verification check for this? Is the goal clear enough to use the /goal command? Run a basic loop, observe where it stalls, fix the underlying system, and then iterate. Start small.
Which brings us to a critical question to leave you with. If you don't start handing off these repetitive tasks to an agent today, how much of your valuable time are you going to lose tomorrow? It's time to stop acting as the manual stop condition, open up your terminal, try out those /goal or /loop commands, and start orchestrating your true value as a developer. Thanks so much for joining me for this explainer. Now get out there and go build the future.